My name is Mark Singleton. I'm an inventor. Starlink Systems is my company. For some years I've been interested in fiberglass or FRP, but not as most people know it. There is an advanced process called pultrusion that makes continuous profiles on a machine that turns fiberglass into an engineering material. It's as strong as steel in tension and compression. It's a quarter of the weight. It doesn't rust or rot. It has better thermal properties than steel, and the more you make, the cheaper it gets. It has two drawbacks. It can't be welded, and it's not as stiff as steel. There are ways of improving stiffness. Firstly, by making hollow sections, which the process lends itself to. Secondly, by building them into trusses, because trusses turn flexing loads into tension and compression loads, where pultruded fiberglass is strongest. Building trusses out of fiberglass box and tube depends on having a way of joining box and tube that can't be welded. And that's what I've invented. It's called SpaceLink, and it's the outcome of an Innovate UK feasibility study last year. The SpaceLink joint uses no metal or adhesive, and it's demountable. It's quick to make, it's cost effective, and it's been tested to 70 kilonewtons in tension at Coventry University. A 6-meter truss was built that supports the same load as a 305 by 165 steel I-beam, but at 17% of the weight. That's 41 kilos against 240 kilos, the difference between 2 men and a crane. SpaceLink competes with steel. It's as strong as steel. It's a fifth of the weight. It uses less energy in manufacture, in distribution, and in handling. And it saves energy in use because it solves the intractable problem of thermal bridging in steel frame buildings. It saves maintenance because it doesn't rust, and that's one reason why it costs less. SpaceLink offers a greener alternative to steel with competitive advantage. My background in pultruded fiberglass covers water treatment to house building. The Starlink house was the first all FRP building without concrete, without steel, without structural timber, without nuts and bolts. 3 stories high, it meets passive house standards of energy efficiency and resists flooding. SpaceLink enables pultruded fiberglass to compete with steel. Innovate UK have made it into a case study, and out of 84 projects at Collaboration Nation, it was voted the coolest pitch. Their words, not mine. A patent has been applied for, and I'm in discussion with steel users like Maybe Bridge, who see the potential of fiberglass in their business. It's already the fastest growing sector of Lionel Kennedy's flooring business. I'm looking for partners to exploit the technology with. The technology is adaptable to a wide range of applications, and that's one of my strong points. The entry cost is low, and the market is as big as steel. Typical applications are long-span roofs that are half the weight of steel roofs and energy efficient. Low maintenance, low-cost infrastructure. Lightweight bridges that can be delivered as flat packs. Structures for the railways that are being electrified. Steel transmits electricity, fiberglass doesn't. Durable marine structures that don't need painting, and demountable structures for temporary events, where the only heavy metal should be music at pop festivals. Thank you.